Okay, let us consider the inverse function of tangent. Let us say y is tan inverse, and we need to find the first derivative of this. Okay. So hold on a second. Make some little change right here. Okay. Y is tan inverse of x. What does it mean? It means that if we take tan both sides, right, it will be the same. That is the best way to memorize this. And tan inverse is the inverse function of tan. Therefore, they cancel each other. That is the properties of inverse function. Or it means that tan y is x. Okay? So now let me draw the unit circle here, and you help me to determine where the domain of it is and where. So we know that this axis is cosine axis, right? And here is sine axis. We have already proved in class, okay? Then for any angle alpha in the unit circle here, the tangent of this will be the line coming from the origin to that angle, and wherever it cut the red line here, the tangent line, that is the value of it, okay, at this value. So the tan inverse, the range of tan will be from negative infinity to infinity, right? So let us talk about the tangent line, the tan function. We know that the range of it is from negative infinity to infinity, right? The domain of this would be any angle from negative infinity to infinity. But we consider the one-to-one function, right? One-to-one, it means that we consider the range from negative infinity to infinity of this tangent function. So where is the domain of the one-to-one function of tan? We know that for any angle between negative pi over 2 to pi over 2, it will cover all the range from negative infinity to infinity, right? You see it in the graph here? So any angle between this, then tangent of this will be the connection between the origin and the line, wherever it cut the tangent axis. Okay? So therefore, the inverse of the tangent line here, the tangent function, so it will take the domain of this to the range of this to be the domain, right? From negative infinity to infinity. And the range of the inverse function of tan will be the domain of this. It means negative pi over 2 to pi over 2. So in short, the domain of tan inverse is from negative infinity to infinity. And the range of tan inverse is from negative pi over 2 to pi over 2, right? Do you have any question? Yes. Well, the convention, we pick this interval to be the domain of the one-to-one function. It is definitely, we can pick from pi over 2 to 3 pi over 2, and it still cover the whole range. But convention, we pick the simplest forms, range, domain, okay? So convention, we all agree that. Okay, now we have the inverse function of tan. We know the domain and we know the range. Those are very important, so that is why I want to remind you. But now, let us focus on computing the derivative with respect to x of the function y, right? Or we call it y prime, okay? What we know is that tan y is equal to x, right? Now, implicit differentiation tell us what? What should we do in this step? Yesterday when we studied? Anybody help me? So we need to find the derivative of both sides, right? Very good. So we take derivative with respect to x of the left-hand side. It should be the same as derivative of the right-hand side. Thank you, Daniel. So now in the left-hand side, remember y is the function of x, right? It means we need to take the chain rule. And the chain rule of the left-hand side, what does it mean? Yes, derivative of tangent y with respect to y and multiply with dy over dx, right? Very good. And the right-hand side, what is it? Yes, it is 1. Very good. So this is a very important step. The chain rule is right here. And do you remember what the derivative of tangent is?
Secant squared.
Secant squared. Very good. It is secant squared of the variable y, right? And dy over dx, it is y prime. Another way to write it. Nothing. So, Gregory, thank you. So now what we need to find is the derivative is y prime, right? It means, what should we do to get y prime in this case? Yes, we divide both sides by secant square y. Very good. Okay. Now, we want to write in terms of x, right? So, but now it is in y. We wonder if we can write it in terms of x. And the properties of, let me see. 1 plus tan square x. Do you remember what it is? The right-hand side. Very good. It is secant square. You can do it easily because now we can write it this way. Tan square is sine square divided by cosine square, right? We can prove it easily. So because tan square is sine square over cosine square, and this is a whole number, this is a fraction. How can we add them up? Okay. We find the common denominator, very good. So then we multiply the common denominator here. And somehow we multiply with cosine square. We need to divide it by the same amount to make it even, right? But now with this method, they are two fractions and they have the same denominator. So we can add the numerator up and it becomes cosine square x plus sine square x divided by cosine square x, and sine square plus cosine square. What is it? 1. Yes, it is 1. And 1 over cosine square, which is the secant. Okay, very good. So from this, therefore, we can write everything in terms of tan, right? So therefore, y prime will be, instead of writing things in terms of secant, we can write it in terms of 1 plus tan square. And in our case, this is in the variable y, therefore it should be if we substitute secant square by 1 plus tangent square, what do we have in the denominator here?
1 plus tangent squared y.
Very good. Who was talking?
Catherine.
Catherine. Very good. Thank you.
Mm-hmm.
So now it is 1 plus tan square y. Very good. So now let us go back a little bit. Tan y, what is it? It is x, right? So it means that we can replace tan y by x. It is? Very good. So now, in the end, we know that y prime is 1 plus x squared, 1 divided by 1 plus x squared. Very good. Or we can write it d over dx of the inverse function of tan will be 1 divided by 1 plus x squared. Is it clear? Okay. So we have one more formula. So you can apply this in the test. Okay. We prove it here. You can use it. So this is what we have. Now, very good. You can go home and do this. D over dx of cosine square of x. Go home and do this. Prove it. It's not difficult. And many other terms. But now, let us do this example. Can you follow? Is it too fast or very good? So now, let us take a look at this example. Differentiate the function y is equal to 1 divided by inverse function of x, v, if we're given f of x is x arctan square root of x. Okay, this is the question. And what we need to do is to find okay, the first example, d over dx.
No worries. Get ready to stress my nigga. All you gotta do is what is it? See it right there. Oh yeah.
Here's what I found.
Mm-hmm. We got Cortana.
Sorry.
Cortana. Only good thing about this laptop.
Okay, now d over dx of y. And we know that y is this function, right? 1 over sine inverse. Remember, this is sine inverse, not reciprocal of sine function. Be careful. Okay? These are two different things, so be careful. Or sometimes sine inverse, we call it arc sines. They're the same thing. Okay? Or similarly, arc cos and arc tan will be tan inverse. Okay? Very good. Now let us go back to this derivative. So which formula should we use here? Quotient, right? Quotient. So f over g derivative of this equal to what? G. Very good. Thank you, Daniel. So we know this formula, okay? So we can apply to this. Therefore, d over dx of 1 over inverse of x. So will be, so what is it now here? Louder, please. Very good. 1 prime, right, or 0 times the denominator, which is sine inverse of x. Subtract what?
Minus the, like, -1 times the derivative of.
Very good. Derivative of sine inverse here, right?
Mm-hmm.
The number 1, we just rewrite it here. And the denominator square, right? Denominator square, which is sine inverse, and then square. Okay? Very good. We didn't do anything new, just apply the formula. But now, 1 prime. 1 is a constant. So what should it be? 0. Very good. 0. So therefore, it would be 0. So here, the numerator becomes, and remember, -1, we don't have to rewrite it, but derivative of sine inverse, if you don't remember, let me just write it down for you because we proved it yesterday. It was 1 divided by square root of 1 minus x squared. Okay? From the formula. Remember, we need to write it carefully. And the denominator is sine inverse and then square. Okay. This is a fraction divided by something else, right? So what is it? Divided by something else here. We can change from division to multiplication, right? By what is next here?
You do it times the inverse of sine squared.
Very good. So in reciprocal of sine inverse squared, which is 1 over sine inverse. So do it slowly and carefully. Very good, right? Now it's easy. Just multiplication of 2 fractions. And then it will be what is it? So 1 times 1 will be 1, right? And the denominator will be the product of these two. Okay, is it clear? Yeah, it's not difficult. Just do it slowly, and you'll get it. Very good. So do you have any question? Was it you, Catherine, a few minutes ago? You commented?
Yes.
Thank you. So this is the question A, and we're done with that. Let us move on to B, right? B is this function, okay? So we want to compute the derivative of this guy. And which formula should we use here? Perfect. Product rule. So in this case, it is the product of 2 functions. One is x, and the other is the function tan inverse, okay? So it will be?
One.
F prime, which is? Very good. Perfect. F prime g plus g F prime, and g is this, yeah, f and g is here. Now, x prime, which is? Very good, 1. And arctan, we don't have to do anything, we just rewrite it, right? And x here, just rewrite it. And recently, we proved that tan inverse derivative is 1 over x squared plus 1, right? Okay. Now, what do we have in the end? A number times arctan will be arctan, right? And here, what is it? Yes, x over x squared plus 1, right? Very good. That's it. Is that okay? Is it clear? Very good. So, very good. Now, another example. Okay, we play a lot with inverse of a trig function. Let us go back to find y prime for x cubed plus y cubed is 6xy. Okay? Look at this. Here, from this equation, this implies that y is a function of x, right? We can somehow write y in terms of x, but it's really difficult. We don't know what it looks like yet, but the implicit differentiation allows us to compute the derivative of this. That is the beauty of it. Right? So what should we do to find the y prime in this case? Very good. So when we take the derivative of both sides, in the left-hand side, it will be d over dx of the left-hand side will be d over dx of the right-hand side. We haven't done anything yet, but now, okay? Which formula should we use in this case? It is derivative of a sum, and it will be a sum of derivatives, right? It will be d over dx of x cubed plus d over dx of y cubed. And the right-hand side, is very tricky right here. What is it? So before you do it, let me just mark it here. There are two functions right here, you see? One is 6x, the other is y, where y is a function of x. So this is a product, right? So we should be very careful. And what is it? Help me, please. Very good. Derivative of 6x times y. Okay, and? Very good. Yes, 6x times derivative of y prime. Thank you, Jamie. Oh, sorry, Carson, right? Thank you. Thank you so much. So now, okay, and one more thing. Here, this guy, we should use the chain rule because y is a function of x, right? Do you see it? So we should be very careful. So before doing that, we need to compute derivative of x cubed, and what is it? Perfect. 3x squared And here we use the chain rule. It means derivative d over dy of y cubed times dy over dx, right? Chain rule right here. And the right hand side, what do we have? Yes, derivative of 6x gives us 6 and multiply y plus 6x times y prime, just rewrite it. Now from here, we can apply, it is simply d over dy of y cubed. And this, we just rewrite it, 3x squared. And what do we have right here? Yes, 3y squared. And here dy over dx, which is y prime, right? The right hand side, we just rewrite it. Thank you. So now what we need to find is y prime, and we see it in both sides, right? What should we do now? Yeah, we somehow bring everything into one side and everything else into the other side and see. So now let us bring y prime into the left and other terms to the right. And what do we have here? In the left-hand side, it is 3y squared, y prime. And if we subtract both sides by 6x, y prime, the left-hand side will be 6x, y prime. And the right-hand side, what is it? Very good, 6y minus 3x squared. So we subtract both sides by negative 3x squared and negative 6x y prime. Now, the left-hand side, y prime is a common factor, right? So what can we do with this? Yes, we can factor it out. Very good. Thank you, Yasini. So we factor it out, and what do we have here? Yes, 3y squared minus 6x, and the right-hand side, we just rewrite it, right? Very good. So in the next step, what should we do? Very good. We need to divide everything by the parameter of y prime right here. It becomes, therefore, y prime is 6y minus 3x squared and 3y squared minus 6x, right? Huh. Can we simplify it? Yeah, we divide numerator and denominator by 3. And the right-hand side will be, if this divided by 3, it will be 2y and, thank you, and the denominator, thank you. Was it you, Remy, or Gregory? Thank you. Thank you. And so, that's it. Okay. That is how we can find the y prime. It's beautiful, right? We don't know what y is, but we can find its derivative. Okay. Now, before Going home, let me review a little bit about the inverse function of exponential function, so that tomorrow when we come back we can do it faster. Okay, you have time to go home and review it. So far, do we have any question here? Very good. So let us move on to the chapter 3.6 a little bit. Derivative of logarithmic functions. Okay. Again, let me start with this. Suppose a function f of x is defined as a to the x. This is a function. And we care about the number, the base, where a is positive, and at a is equal to 1, 1 to the anything will be 1, so we are not curious about this. So we don't care about a is equal to 1. So what is the domain of this exponential function? Domain is where we can take the value, right? Very good. From negative infinity to infinity. And what is the range of it? Daniel say that it is from 1 to infinity. How about if a is very small and x less than 1, right? So it means that the range will be from 0. Yes. Yeah, so be careful. It is from 0. Very good. So we see that the range of this is from 0 to infinity. Zero to 1, you see that, and 1 to infinity. Is it what you mean? Yes. Okay, look at this. It is a very interesting question. Okay. A is not 1. But look at this. The domain is from negative infinity to infinity, right? So when x is equal to 0, what is a of 0? A to the 0. So, but this is a very good question. Yeah, any numbers raised to the 0, why do we a to the 0? It means that a to the 1 minus 1. Do you agree? And a to the 1 minus 1, it is a to the 1 divided by a to the 1. You see? And numerator and denominator have the same value, therefore it should be 1. That is why for any numbers raised to the 0, it should be 1. Therefore, the range will be from 0 to 1 and then from 1 to infinity, or their union will be from 0 to infinity. So is it clear? Very good. So if you don't remember the formula, just look at this. You see it? Okay, now let me just bring this guy down a little bit to have some space to write here. So now, and we know that this function is 1 to 1. It means any value of x gives us one value of y. Therefore, it has an inverse. We call it g of x, which is f inverse. The inverse function, it will take the range to be its domain. So now here it is domain, right? The range of this guy is from 0 to infinity. And what is the range of this inverse function? Very good. Thank you, Gary. So, the inverse function will take the range of the function to be its domain, and the domain becomes the range of the inverse function. Okay? And in this case, the inverse of the exponential function, we call it the log function, logarithmic function. And it is, we define it. Y is log base A of x, which means x is a to the y. Okay? This is the inverse function. And remember, we care about a is strictly positive and a should not be 1. Okay? Very good. So you can review all these things and by going to the department website, go to the course Math 1021. It is download the notes in section 5, section 5. It's very clear there. It's a good source for you to find. So a very important properties of the inverse function is that if f inverse is the inverse function of the function f of x, then f inverse composite f applied to x will be the same as f composite f inverse then applied to x, which is x. This is a very beautiful properties. So then we have the formula. So these are the inverse function and its properties. And now we have the derivative of logarithmic functions. Okay, I think we can continue tomorrow, but we save a little time to discuss what we can do with the group chat, right? So any of you can ask question there. I'm quite busy, especially in the beginning of the week. So I may not be able to answer you all the time, but I will try. But for any one of you, if you know the answer and help our friends, feel free to reply to them. Write your solution, explain it clearly, and send it to the whole group. So at the end of the week, I will summarize and pick 5 people who is most active there and give good answers to give 1 extra credit, adding up to the coming exams, okay? Is it better? So I hope that you enjoy and help each other well. Thank you so much and see you tomorrow. Bye-bye, everyone. But I will try to do it this afternoon, and hopefully I will finish it by tomorrow. Okay? So you have a good one? Josh, you can find the email yesterday. There's a link so that you can join the group chat.
I was just gonna say that like I'm kind of behind since I wasn't